Now let's try to understand the geometric intuitions. What is the geometrically intuitive this k-means algorithms is? So the first thing that the k-means algorithm that we are going to discuss, this is the most popular and the simple one among all the clustering technique. This is the most popular one, popular as well. This is the simple one among all the clustering technique. This is the first thing that we have to remember. The next thing that you have to remember, the basic concept of, we have to know the basic concept of k-means. What each means already we have learned in the statistics chapter, probability and statistics, what it actually means. So the basic concept of mean that we have to know. This is the second concept and core idea that I am going to tell. So now the next thing that it's how much type of means, how much variants of k-means there have. That also we will learn in this series of lectures. So how much variant we have? Variants of k-means. Okay, these kind of things we will try to discuss in this k-means chapter. Okay, so now let's try to find what is k here. What is k is denoted here? The k in the k-means in the k, the name, the reasons behind it. The k denoted here the number of clusters. It's denoted the number of clusters. How much clusters we have in our data set? Number of clusters. How much clusters we want in our data set? That's the thing we have. So the generally the k that we have, that means the number of clusters. Now what is, already we have learned this concept in the classifications, in the regressions, there are hyperparameter. So in unsupervised model, means in clustering technique, k is as well, you can look like these things as a hyperparameter. Hyperparameter. Okay, we have various many of techniques, causalizations, like idea also here applied. Also as time progresses you will see these things, but the k-means chapters, the k is denoted is one type of hyperparameter that we have to tune this thing, and they have to choose the best k among all the things. That things we will see as step by step. So now let's try to visualize these things geometrically. Suppose let's take the data we have is a two-dimensional data. Because two-dimensional is easy for our visualizations. Suppose let's take first feature is f1, the another feature one is f2, and the data that we have is look like that. Look like this type of data that we have. Like this kind of data. Okay, and easily you can see this is a one cluster of data. This is another cluster of data. This is another cluster of data. Hence I'm talking about this group of data. So here we will see naturally here we have three groups. We have three groups of data. So here k means number of clusters. So here k is what? Here k means k is equals to 3 here. So here k is equals to 3. Now the thing that we have to know, the set that we have to build, the main intuitions that we have going to do. So the set, suppose let's take this the S1 set. Suppose let's take the S2 set, the S3 set. The relations will be like that. Suppose we have a data set D. Suppose let's take D is our data set. So the union of its set, S1 union S2 union S3, it will be the whole data D. Okay, means we are going to partition the data. And the intersectors of the H term, it will be null set, empty sets. If you take in the intersectors of H, pair of clusters, it will be 5 is 2 is 3, it will be 5 as well is 1 is 3, it will be 5. Yes, this is a simple partition all the data sets. Like here, another thing that we have to know here, also an important thing, that here we have to find some centroid among all these points. Suppose let's take here we have some centroid, here we have some centroid for this set 2, here we have some centroid. Suppose let's take this is centroid C1, this is centroid C2. Suppose let's take this is a centroid C3. So the second thing, that to find the centroids C1, C2, C3 is just centroids here. Is just centroids here. Okay, and H1, H2, H3 are the clusters here. The clusters here. That's the now the main job that we have to do. We have to find the centroid. That's the main challenge in the k-means. So the main challenge here, the main challenge that we have to do here, we have to find the k centroids. So if we choose the hyperparameter k, then we have to find the k centroids. Here in this picture we have 3, k is equals to 3, we have 3 centroids. So first challenge is here, we have to find the k such centroids. C1, C2, C3, like that. That's the first challenge. Now the second challenge, that we have to find such kind of k sets for its corresponding to for its centroids. First sets S1, S2, S3 up to Sk. The second thing. So if we have such kind of k clusters, if we have such kind of k clusters, if we have k clusters, then the main challenge here, we have to find these things. Now how we'll find? Generally the rule that we have already we have seen in statistics chapter. Find. So for finding the mean means, just you can remember these things as a mean of the sets. Okay, means of the sets means, suppose let's take for each sets there have n number of data sets. Suppose let's take for each data sets there have n number of data points. So if there have n number of the so the ci for each data sets, it will be like that. Means I'm talking about xi. It will be denoted as j. So where xj that belongs to the set sj. Si, because I am going to find the mean si. Okay, means if in a single cluster, if there have n points, this is the general, means these things are called in general the geometrical mean. These things are called the geometrical mean. Also there are another definitions, arithmetic mean, that's the another thing. So this is geometrical means. So these things are called the mean point to the set Si, means to the cluster. That's the thing. Okay, so if we know the clusters, then we can easily find the mean. It's the easy task. But how we will find this cluster for our data sets? We have a raw data sets. Anything we have no. So from the data sets, we have to find the clusters. That's the main job we have. If we have the clusters, then finding the mean is an easy task. That have no problem. Main challenge is how we will find this set. And another questions that rise, if we find the centroids, then there are various techniques to find the sets, to generate such kind of sets. So these things are dependent on each other. And the first questions, So the first questions that comes into our mind, the challenging questions. So the challenging questions, that big challenge that we have. How to find such case and how to find. How to find K centroids for the K clusters if we choose the hyperparameter as K. How to find these things for such kind of K clusters. Okay. So if we let's take their have a technique, we can we by simply using this we will find this K centroid. Okay. Suppose let we will see these things how to find this centroid, but suppose let anyhow we'll find this K centroid points anyhow. Anyhow we will find this. Now if we find such kind of K centroid, then how we'll find from these centroids, how we'll find such kind of K sets? That's another question that have to come into our mind. How to find this K sets means K cluster. That means I'm talking about this cluster, this cluster, this cluster, such kind of things. How will find this thing? By the concept there we can easily apply by simply using the nearest point technique. Nearest, apply this concept. Now let's see. Suppose let's take the point that we have. Suppose let's take we got the centroid here. Suppose let's take we got the centroid here. Suppose let's take we got the centroid here. Anyhow, some using some techniques we calculated there have some centroid, there have some centroid, there have some centroid. Now from this centroid, how we'll find such kind of K sets? Okay. So this concept is nearest point concept. Means suppose let's take here we have some point. Here we have some point. Now first we calculated the distance from each centroid. First we calculated this distance from here to here. Now we calculated this distance from here to here. Now we calculated this distance from here to. Suppose let's take here the distance is for here D2. Here the distance is suppose let's take D3. Here the distance is suppose let's take D1. Now among all the distance, so you have to choose the minimum one. So the minimum of all this distance, all these di's. So here minimum is what? Di. Now we will consider this set is lie on this cluster. Okay, this. Now we have again the same things we will repeat here. Suppose let's take we have got a point here. Suppose let's take we got it from here. Now first thing that we have to do, so we have to find the distance. Similarly from suppose let's take we have to find the distance from here to here. To find the distance from here to here, we have to find the distance. Among all the distance, we have to choose the minimum one, and according to distance, we will put this set on that cluster. Just the same things also applicable on its data point. So let's take here we have some point. Here we have some point. We have to distance here to here, here to here, here to here. This distance. And based on the minimum distance, we'll put this data point on that cluster. On that cluster. That's the things that we have to apply here. Okay, I think you got the idea how these things are, but they have some drawbacks also. As time progresses, we will see what is the drawbacks behind it. But this is the main core idea of the main cracks of the K-means technique. Okay, now we'll see as next video we'll see how these things are actually there are some drawbacks. We'll see these things, but this is the main concept behind it, behind the K-means algorithm. So the K-means algorithms that we are going to discuss in this series, the K-means algorithm, this is the main crack of the concept. This is a simple geometrical concept behind this idea. The K-means algorithm that we are going to discuss. So these things are simply based on the centroid based clustering that we have. Centroid based clustering technique. Centroid based. And there have also the various kind of technique we will learn as time progressed. So the another kind of clustering technique that we are going to learn, and hierarchical clustering technique. Hierarchical clustering technique we will learn. And the one is density based clustering technique, means these things are the simple centroid based, and also we'll see the density based. We'll see as time progresses, we'll see these things, but in the k-means chapter we will be these things mean based on the centroid based clustering technique. So to find the centroid that we have seen, so they have the most popular technique. So the most popular technique there we have apply that we'll see in the next lecture. So the algorithms that will Lloyd algorithms. Lloyd algorithm. Okay. In details geometrically we will see how to find to this from a data set. This is such kind of k centroids. Let's see. Let's in the next lecture we will see these things by simply using the Lloyd algorithm. Okay, that things algorithm that we'll see. I think from this lecture you got some geometrical idea how the k-means technique actually work. You got some idea, I think. Okay, so now in next lecture we'll see how these Lloyd algorithms are actually work behind the k and to find the centroids. If we find the centroid, then that's not easy. That's the easy thing. The main challenge problem is to find the challenge. The big challenge here is to find the k centroid. If we find it, then it's so easy. Okay, and also there are some drawbacks. That's also we have discussed. But in the next lecture, we'll see how the Lloyd algorithms are useful to find the such kind of k centroids. Okay, we'll see these things in the next lecture.